in this part. So I believe 2 people got this question correct based on the Google submission.
I'm
So,
pretty sure I got that one. Right.
Yeah.
so does anyone have any idea before I go? Okay, True, go ahead.
Okay, I don't know if I got this one right or not. Would you just do 5/6 time and you multiply that 4 times for the first 4 times and then multiply by, so like that's 5 to the 4th over 6 to the 4th, or 625 over 1296, and then you just multiply by 1/6 and 625 over 7776.
I guess that looks good. So like, let me explain why we have 5 over 6.
Am I wrong?
We want to get a sum to be 7, right? So we can have like 1 and 6, or you can have 2 and 5, or 3.
Wait, the sum to be 7. Oh yeah. Okay.
Right? So is that what we are looking at, right? So the probability that a 7 is obtained on the 5th task, not before, when you have the like pair of dice, I can see, yeah, the sum should be 7. And you can have like 4, 3, or whatever. Like we have like 6 of these cases. Like we can swap this order because we have 2 different dice.
Oh, I see where I went wrong. Okay.
So
Oh,
no,
I didn't.
the probability of getting a 7, I will say, is 6 options, right? 1, 6, 6, 1, 2, 5,
Yeah,
5, 2.
1,
And
6. So Drew, your option will still work. 5, 6, and 5,
Yeah.
6.
I got
and
it.
then
Yeah.
go ahead.
You know, I did 5, 6 times 5, 6 times 5, 6 times 5, 6 times 1, 6. I didn't read the question properly because I thought it was just for one
Yeah,
one
same.
space
Same.
instead of the sum of them. Well, I still got it right.
Okay,
Yeah,
that's good.
No,
Yeah,
I misclicked my answer, but I ended up putting 25 over 7776 instead of 625.
It's
I just can't
625.
type.
Yeah. Drew, how do you
Nice.
feel?
I just
Would
can't
you
type. Okay.
just click on a typing question, Drew?
No, that was I messed up 2 typing. I messed up 2 questions this way.
Okay, so we want to get the 7 on the 5th, not before. So we are gonna get the like 1, 6 option. Like probably we can get a 7, which means 5, 6 we cannot on the first flip, first like dice. And the second one we don't want to get 7 either. So that's 5 over 6. We don't want to get this on the 3rd, on the 4th. So, and the last one we should be getting this, which is gonna be our final answer. Like 4 5s, I mean, this 625. And this was, what was this 5 6s? Is it 7 7 7 6? I think that is the case. Any question? Okay, so yeah, that was not too bad. Okay, here's the next one. This was a state team, okay. Each face of a cube is assigned to different integer, and each vertex is assigned to some of the integers values of the faces that meets that vertex. Finally, the vertex number are added. What is the largest number? We must divide the final sum. Okay,
Did I answer this one?
go ahead.
So technically, right? You have. So I thought firstly like a cube that has the faces 1, 2, 3, 4, 5, 6, and then there was another cube 1, 2 that had the faces 1, 2, 3, 4, 5, and 7. Now between those two, right? The difference is going to be of 4, and the reason for that is 7 is 1 greater than 6. So wherever the vertices that are on the face of 6, right? 7 is just going to increase those by 1. So it's going up by 4 each time. So it's probably going to be a multiple of 4. And it says different integers as well. So I think can be proven correctly. So then the greatest possible one should be 4.
I see. Okay, that's good. I didn't come up with that approach. That's a good one. Drew, go ahead.
I did the more stereotypical approach. So I assigned each face A, B, C, D, E, and F, and then each vertex meets at has 3 faces that meet it. So like 3 different faces. So I thought about making a table and doing everything, but then I realized that actually it's really simple because in a dice each face meets the same amount of vertices, so it's equal for everything. So with a little bit of algebraic manipulation, uh, I counted, and since there's 8 vertices and 3 faces that meet at each of the vertices, there are 24 possible vertices. And to divide that among the 6 different faces, that means each side gets to meet at 4 vertices. So that means well, what's happening is we're doing, if we were to simplify this, we now get 4a plus 4b plus 4c plus 4d plus 4e. I forgot 4a through f, which means that for any vertice, the largest number that must divide the final sum would be 4. It's kind of confusing, but like,
No,
get
I get it. That's good. So let me kind of write what you mentioned. Like, here's what I have as the figure. Let's say, you know, we want to find the number in this corner. So this corner has like this face, the number on this top face, and this, the left face, and the face on the back. So there are 3 faces that will be added to get this vertex. I'm going to call that vertex 1. And if you do the, for this one, I'm going to call that vertex like 2. And if you keep doing this, like if you combine all these vertices, so we have like 8 of these, right? So vertex 8. But every time when you find a number at the vertex, you are adding 3 of those like 6 letters. If I say A, B, C, D, E, F are my numbers on each face, and I will just combine some way 3 of these to get vertex 1, and then some of those 3 will be vertex 2. But if you keep adding those, you are gonna have 3 letters in this case, 3 letters in this case, 3 letters in this case, which means there are 24 of these letters. But we do have only 6 of those, which means 24, like divided by 6 is 4, which means these A, B, C, D, F are gonna be actually added 4 times. So we can say the sum of these guys is the same as 4 times A, B, C, D, E, like D, E, F, I guess. Since we know the sum of these could be anything, and then that means at least the sum of those vertices is going to be multiple of 4. So, and then we don't really know if this is going to be multiple of some other for sure. So we can say there must be multiple of 4 at least. Does that make sense? So this was like, you can kind of try a couple examples just to convince yourself, but I think this is okay. Let's see the next one. Okay, let me read the question. I'll let you try for. So consists of the rolling a standard die and tossing the fair coin. The game is won when the die 2 or 5, the coin shows tail. What is the probability the game will be won before the 4th turn? Okay, Vidya, go ahead.
Okay. So the approach that I took this was basically standard casework. So my first case would be if the game was won on its first turn. That would be if the die showed a 2 or a 5, which is a 1/3 probability, and the coin showed tails, which is a 1/2 probability. So currently your probability is going to be 1/6. And that's for this case 1. For case 2, you have to lose on the first turn and win on the second turn. So to lose on the first turn, you have to either get 1, 3, 4, or 6, which is a 2/3 probability, and then 1/2 probability of getting pets. So then that's your first option. So 2/3 times 1/2 would be 2/6, which is 1/3. Okay. All right, and then you have to multiply that same thing by 1/6. I think,
Okay.
yeah. Yeah, because 2/3 times 1/2 represents you losing.
Okay, this is for losing, right?
Yeah, but then you have to multiply that by 1/6 again, such that you win on the second time. And that's 1/18. So that's your second one. So you have 1/6 and 1/18 currently. Your last case is going to be if they won on the third turn. That means they lost 2 times previously, which is 1/3 times 1/3, and they won on the third turn, which is 1/6.
Okay, so should we I'm kind of lost that part, so can you repeat after the 1/18 part?
So for the third case, they have to win on the third turn.
Okay,
Alright? So basically, to win on the third turn, you have to lose on the first two turns. And to lose on the first two turns, it's what turn? 1/3 times 1/3.
okay, so that looks
Or
like,
wait, how's that work? Wait.
Would it be 2/3 times 2/3? Because you're losing?
No. Okay, then no, this is confusing because if you win as 1/6, your losing should be 5/6. But
Yeah, I'm kind of.
yeah, even I'm confused. Somewhere I
Oh,
messed.
yeah, let's restart this. Okay.
okay,
Okay. So
We know
uh
1/3 times 1/2. That makes sense. That's gonna be 1/6. So
yeah.
that means let's just say 5/6 is when you lose. Let's just keep it simple. We don't have to calculate it.
So then the second case would be 5/6 times 1/3.
5/6 times 1/6.
Oh, here's what I'm thinking. Okay. So every turn, how many possible outcomes are there? 12, right?
Okay, yeah. That's
And
good.
then I actually denied the solving this one because I'm dumb. But there's 12 possible outcomes, okay? And then I make this up as I go. Out of these outcomes, only around I believe two of them, only two of these outcomes work. Right, so that's 1/6, right?
Yeah.
Okay, so there's a 1/6 probability that's gonna be one in the first turn. Oh no, sorry. So there's a 1/6 probability that's one
That they'll win.
that the game's gonna be one in the first turn, and then after that it doesn't matter. Okay, so out of the, I believe 12, like 12 to the third probabilities, 1/6 of them are there. Okay, now next if it, oh, you know, now I'm getting confused.
So
Okay,
I think
does anyone have something else before I go? Yeah, go ahead.
yeah, I think I know. So basically, the first, like with the casework, right? So the first case is that they roll 2 or 5. They roll 2 or 5 in the die, which is 1/3 times 1/2, which would be which would be tails, right? So you would get 1/6 chance. Then on the second turn, you have to lose on the first one. That means that you would have a 5/6 chance of losing on the first one, and then you have to multiply that by 1/6, which you win on the second one, which would equal to 5/36. And then on the third one, you lose on the first and second one. So you do 5/6 times 5/6 times the 1/6 chance of winning, which would be 25/216. And then you multiply 1/6 times 5/36 times
No,
25.
you add.
That is correct.
Yeah, you add them.
Yeah, let me write them. So that is correct. I like that. I was about to do that. So like we have two like numbers that we like, right? On the if I wanna like win in the first like turn, we should get like 2/6 on this, and then we need to get a tail, which is 1/2. So this is the winning probably on the first turn basically. But if we don't like win in the first one, maybe we are gonna win in the second one. So we do have winning as 1/6, and but means we are gonna lose 5/6 choice options for these numbers. Okay, so then we have to win the second one instead of the first one. So that is 1/6 option. So we are gonna multiply this. And the third turn, if I'm gonna win, so I'm gonna lose on the first two, which is 5/6 and 5/6. And I need to win on the third one. This is basically what we have. Does that make sense? Okay, so that's like if you add these, like I have 2/16, I can multiply this by 6, which is 30, and I can multiply this by 18, that's 36, and then 30, which is 68, 36, and 66 plus this 76. I mean 25, 91, yeah, I think that's 91, and over 216. I hope I didn't miss anything, so it looks like 91/216.
Yeah.
Okay. Yeah, like just to be clear, like this is the winning on the first turn. This is the winning for the second turn. This is the winning on the third turn. So that's basically our cases.
Can I explain this one?
Let me read the question because let me see the question first.
Example 14. I remember doing this one.
Okay, sure, go ahead.
Okay, so basically this one is just casework, but it's pretty simple because it's cumulative casework. So, so let's say Allison rolled a 2. Okay, there is a 1/3 probability of that happening, and out of that, the only way Allison can beat Brian is if Brian rolls a 1, which also coincidentally has a 1/3 probability of happening, or 2 and 6. So there is a 1/9 probability of Allison winning if she rolls a 2. Now, so we'll write that down, and then now, what if she rolls a 4? If Allison rolls a 4, Brian loses if he either rolls a 1 or a 3. That's half of the outcomes exactly. So that's gonna be that, and there's already a 1/3 probability of rolling a 4. So that's 1/3 times 1/2, or 1/6. So we have 1/9 and 1/6. Now, lastly, if Allison rolls an 8, then there's nothing Brian can do. So there's a 1/3 probability of Allison rolling 8. So we'll just add that up. So 1/9 to 1/6 to 1/3. We take the GCF of this, which is in this case 18, and we LCM, sorry, and we take 1/9 becomes 2/18, 1/6 becomes 3/18, and 1/3 becomes 6/18. 2 plus 3 is 5. 5 plus 6 is 11, or 11 over, and that's how you get 11 over 18.
Okay, so any questions? Like, yeah, it's kind of straightforward. Like, if you choose the 2 for the Allison, so you have 2 options. So we just have 2, 6 probability choosing 2. And if Allison should win, so we should have something smaller for the Brian, which is the only one number is like 1. But we have that number 1 twice, which is right, that's 2 over 6. And if the Allison chooses 4, you still have 2 options, that's 2 over 6. In this case, Brian could have 1, 1, or 3, which is 3 out of 6 option. And then the last one could be 8, so that's 2 over 6. And when this is 8, anything is okay, which is basically 6 out of 6 or just 1. So that's basically the final answer. Okay, that wasn't too challenging. Okay, let's see. Go ahead.
So basically, it's a casework again. So what you would do is you have to find. So wait, I lost the question. Okay, so if Brian, if one cube, yeah, if one cube rolls 1, right, then the second cube has to roll a 9 for it to be 10. But the second cube doesn't have a 9, so there's no possibilities when the first cube rolls 1. When the first cube rolls 2, which is a 1/6 possibility, the second cube has to roll 8, which is also a 1/6 possibility. So there's a 1 over 36 possibility that the first die will roll 2 and the second die will roll 8, which adds up to 10. The next possible number that this happens with is 4. Again, there's a 1 over 36 possibility that the first die rolls a 4 and the second die rolls a 6. And after that comes 6. There's another 1/6 possibility that the first die will roll 6 and a 1/6 possibility that the second die will roll 4. And those are the only 3 possibilities. So you would add them up and get 1 over 36 plus 1 over 36 plus 1 over 36, which equals to 3 over 30.
Is that 3?
Mr. Ishmael, it's 3 over 36, not 4 over 36.
I need to work on adding. I know that. Okay,
Which would equal to 1 over 12.
that's good. So I think that's just cases carefully. Yeah, we can just choose only 2 and 8 and 4, 6. And
Yeah, you could just like you could
Okay.
just notice that really quickly that automatically a pair, since there's no repeats, a pair would automatically have 1 over 36. So then really quickly you notice there's only 3 of these pairs. 3, 3, 7, 2, 8, 6, 4, 4, 6, and then 3, 36, 1, 12.
So this doesn't have the pair, so be careful. So 8, 2 doesn't have, but 2, 4, 6, and 4, like 6, 4 is good, but this
Yeah,
doesn't
2,
have.
8. I meant to say 2, 8. My
Okay,
bad.
but that's good. Like if you have some pairs, that is good to count a bit faster as well. Okay.
Okay, I do not understand this one. What does it mean by the total number of rolling being
Ah,
6?
yeah, this one.
Yeah, this one was kind of confusing.
What does it mean
Yeah.
the total number of
Also-
rolling is 6? Does it
Yeah,
mean
what's the conditions for Brian? How do we get Allison back for rolling? Is it the same rolls? Is it
or does it mean that the sum of the rolls have to be 6 or you
thick?
roll 6
What do you mean by
times?
the sum of the rolls has to be thick?
Like Mr. Ishmael, what happens after Allison, let's say, rolls a multiple, if she doesn't roll a sum of multiple of 3, then after Brian gets the turn, can Allison get the turn back? And how?
In rollings, how does
What does it mean by the total number of rolling
This was
is
like
6?
a very
What
confusing.
does that mean?
Okay, so let me slowly digest the problem. Like it says 2 people have 2 standard dice, okay. And it says 2. Let's highlight this. And Allison started the first roll and at the same time, and then Allison runs multiple of 3, and she will continue to rolling. And Brian starts to roll his 2 dice at the same time. The rule of game is followed by each person until the total number of rolling is 6. Okay, and then what is the probability that Allison rolls the last person? Okay, like here's what I understand. Like we have 1, 2, 3, 4, 5, 6 rolling, and then Allison starts, and Allison will end this game. That's what we have for sure given, and we want to finish the middle of 4th spot. Like we can do a couple approaches. I'll try to make a couple like ideas at least. You can start with simple cases. What I mean by the simple cases, like you can just ignore this 6 because it's kind of complicated. Let's do this with 3. Okay, if this is only 3, so you have A and A, right? Allison, Allison, and then you just need to determine the middle one. And then based on this, find this question. As soon as you have this, make this 4, and then find the second case and see if there's something going on with that. But I'm not gonna do that exploration. I will let you guys enjoy that part. But instead, we are gonna make some sort of organization because this is not too simple problem. So like if the next person is Brian, okay, then Brian should lose to get the A next. If this is like A, that means if the second person is Brian, the first person has to lose. So that is kind of the rule basically. But how do you know when which person is winning, when which person is losing? So it's not really always. There are too many cases, especially when you have 6 rolling. So for that reason, let's think about like 2 different cases. Like I could have every single of these 4 spot A's, which means Allison is gonna keep getting multiple 3s. That is one possible option, right? So Allison could have all like winning, basically all multiple 3s. That's one thing she can do. I want to take that as like maybe one case where like we have like how many rolls? We have like 6 rolls. We already did the first roll, so we need 5 more basically. And if the previous roll is like Allison's roll is like winning, then the next one is gonna be still Allison. So what I'm trying to say, if the like n-1, let's say n is just the number of rolls, term, let's say this is the n-1 roll, is a winning by Allison or like roll by Allison, then the next one, the nth roll, I will say, is also will be by Allison. This is something we can say. Is this clear so far? If the previous term, like if the previous roll was done by Allison and minus like one roll is by done Allison, which is gonna be like multiple of 3 basically, then the next roll should be done by Allison as well. And this is one case, and that will complete everything will be done by Allison basically. And the second case is slightly different. Maybe the previous like roll was done by Brian. Maybe he got that like turn. So then I will just say n-1/3 roll actually done by Brian. Then the next one is gonna be done by Allison because we don't want to get Brian again. The reason why because we want to end up getting this final rolling by Allison. So that's the case. And then let's say the nth roll is gonna be still by done Allison, but n could be 2, n could be 3, n could be 4, and stuff like that. So n is just in the turn, right? So we have 6 space, like 5 different turns, if possible. And this is the 2 different cases, but I will try to see if we can get some expression based on these 2. For example, the first one, I'm gonna take probability of, like, we are considering Allison only. So Allison is our guy. Like in this, like first one, Allison is gonna have a number on the n-1th roll that is multiple of 3. But the question is, what is the probability of getting a multiple of 3, right? So we should try that as well. So like if you choose like 3, so you could have 2 plus 1 or 1 plus 2 because there are 2 different dices. And that's just 2 ways. If I have 6, that could be like 1 plus 5 or 2 plus 4 or 3 plus 3. And if you double this one, that will be 5, 1, 4, 2, which is going to be 5 plus 2, which is 7 so far. So let me write this 2 plus 7. Okay, and are we good so far?
Yeah.
Okay, how about 9? How many ways can we get 9?
9, okay, 12, 11, 10, 9, 4.
4?
Yeah.
Okay, how about 12?
1.
Well,
Okay, so if you add this, that will be 7, 9, 10, 14. Is that right?
7, 4, that's 14, yeah.
it's a probability. So
So should we take those separate or together? Let me double check. So we wanna, the dice are, maybe we should take only one of them. Let me think about that. Like we could have 5, 1, 1, 5. That's
I think you take that over like I think 36 perhaps, because you have all the different sums, which is possible with 36 different ways. The total sum is 36 since you have 1, 2, 3, all the way to 2 to 12, right? And there's 36 different ways to sum.
okay. But
I
is
think
this
it could be
like, are we correct with our counting? Because I don't think we should get 14.
mm,
So like we can get 6 and 6, that's 1, that's okay. And then 9 is,
the answers according to the Google sheet, it's definitely not 14.
okay, so that's what I'm confused a bit. So
Yeah.
that's 4, 5, and then we have like 5, 4. And
But
that's
those 4 things, right? You have 2 different ways, the Allison or Brian. So basically you have 16 different ways that can work. In
yeah.
simplest form, you have 16 different ways.
okay. So okay, my question is, how do I get this 7? I just see something wrong with
7
that.
is the 6. 1 and 5, 2 and wait.
That's
Yeah,
5.
how do you get 7?
This is 5, so that means this is
12. Okay.
so that is good. So like this is 12 now. So the total case is 36. So the probability of getting a multiple of 3 is just 1 over, like I would say, multiple of 3 is 12 over 36, which is 1 over 3. Okay, so now it's good. So that is 1/3. If the first, like, and n-1 term, like the roll by Allison is a multiple of 3, which is just a 1/3 probability, right? So we can just say, if the n-1, which we don't know the probability, we need to multiply this by 1/3 to get the next probability. Because if that is multiple of 3, which is going to be 1/3 option, then she's going to roll again. So then I will say this is equal to probability of getting the nth roll. So let me repeat one more time. So this is the previous like term that Allison had. If she had some sort of probability of n-1 like roll, which we don't know, maybe multiple of 3, maybe not. But for her to get the next roll, which is going to be the nth roll, then she has to get a multiple of 3, which is only the case if this is going to be 1/3 like option, which is we just as 1/3 probability that she's gonna get a multiple of 3. And that is gonna be our next probability. And that is the first case basically. And the next case is the second one. Then we are gonna get the n-1 roll will be done by Brian, but the next roll should be still done by Allison, meaning that, you know, we said the n probability of n-1 was the for Allison's roll for the n-1 roll, then the Brian should have that number to be 1 minus that number because the total probability is just 1. So for the second case, I will say 1 minus like P of n-1 for the Brian. So that is the probability of getting like Brian in the previous roll. And if we want Brian to lose, because we want to get the next roll by the Allison, so we need to multiply this by 2/3 because winning was 1/3, losing is 2/3. So Brian should lose on the previous term, so we can get the next term for the Allison. Does this make sense? Like this 2/3 is losing, so Brian will lose on the
Oh, yeah, okay.
n-1 roll because
So Brian and Allison have the same condition.
yeah.
Okay.
Because yeah, they are the same rule, like stuff. And then Brian should lose in the previous turn, and then the next turn should be
Yeah,
done.
that's what it means by the rule of the game is followed by each person. Oh.
Yeah. Okay. So the question is now, what should we do now? Like this is equal to what? This is equal to P of n for the second case, right? And then we should be adding these two cases because these are the only two different cases that we could have, basically. So let me try using different color. So if I add these two, like this number and this number, so that's kind of my probability. So let's say Pn is equal to Pn-1 times 1/3 plus 1 minus Pn-1 times 2/3. Can you guys clean this a bit? If you multiply like this by 1, that's 2/3.
2/3, and then minus P and minus 1.
So that is going to be minus 2/3. This is 1/3, which will be minus 1/3.
Yeah.
P of n-1.
Yeah, equals to P to N.
And if you are wondering what this equation looks like, so we do have a special name for this equation. Does anyone have any idea about the name for this equation?
Diophantine equation? I don't know.
Oh, it's not
It's
Diophantine.
not that one. It's recurrence equation. Like we have
Oh,
a
yeah,
recurring-
recursive.
because you're like, how do I know this is recurrence? Because my next term is determined by the previous term.
Yeah, it's like
And I
everything's
do,
like interlocked.
yeah, I do remember last year, I'm not sure if this was chapter or state, there was the last question about the, I guess, target number 8. If I'm not mistaken, that was also recurrence problem. The way that we understand that's recurrence because the next like roll is determined by the previous one. And now we have the recurrence going on because P of n is just determined by P of n-1. And if you just plug some values for n, you get the next number. So let's try that as well. And you may even get something better from this expression. I'm gonna clean this part a bit. So can you guys plug n equals 2 because we cannot have n equals 1 because n equals 1 is our first roll, which was already done by Allison. So that's why we don't need that. So what is like P of 2?
P of 2 times.
That was 2/3.
2/3 minus 1/3 of P of 1.
What is P of 1?
P of 1 is with Allison rolls.
Allison's winning, right? Which is 1/3.
Yeah.
Okay, so that means this is 1/3.
Like 1/3 is 1/9, and 2/3 equals 4/9. So you have 3/9, which is 1/3 again.
Okay, so how about P of 3? So you will get 2/3 minus 1/3 times P. Now this number will be 3, this number will be 2. So P of 2 it was 5/9. So you will get P of 2 as 5/9. that's 5/27. If you multiply this by 9, that's
You get 18 over 27. So
18 minus 5 is 13/27.
Yeah.
Okay, and then P of 4 should be 2/3.
1/3 times 13 over 27. So then 13 over 81. So you multiply, so 54 minus 13, 41 over 81.
Thank you. And then P5,
P5 2/3 minus 1/3 times 41 over 81. 41 over 243
Yeah, so that's 41 or 243.
times 81, 162
So 162 over
minus
243 minus
41. So
41 over
121 over 243.
Yeah, that's the
Yeah.
answer.
is it 121? Yeah, okay.
Yeah. So it's
So,
basically just a little bit less than half.
yeah. So here's my challenge for you guys. You know, we said we got the equation right here, right? P of
Yeah.
n. And if we plug a few numbers, we were able to get P of 5, which is our 6th row. But if I ask you to do this like 16th row, okay, or maybe 125th row, you don't want to do this for every time, which is going to take too
Yeah.
long. But there is a way better approach from here. So if you look at this expression, like the hint is like you're keep multiplying by 1/3, right? P of n minus 1 is multiplied by 1/3 and stuff like that. When you multiply a number by the same number every time, what do you guys get?
Arithmetic. What?
Geometric series, right?
Oh yeah.
So, which is why I want you guys to think about this, if you can make a geometric series from this, because if you can, then you can get any number of rows from this expression. But for this question, we don't really need that. We just have 5 of these. That's enough to plug it. But you can make this a bit better equation.
To make it such that your common like multiplier or difference is going to be like negative 1/3, and your initial term is 2/3. That will be your geometric series. And then if you want to find like
Yes, I'll leave it as a challenge. So just try and see if you can find that geometric series from this expression. But at least this question was way challenging. And another thing that we see now, recurrence is a challenge for everyone. So we want to work on that as well. Okay. So let's see the next one.
oh, this one
This
I
one's
got.
easy. It's easy.
This one was easy.
It's easy.
Yeah.
Okay, go ahead.
Who, me or Vid?
True, but I think I saw you.
Oh. So basically, we just need to list every dice probability that's greater than or equal to 8, which isn't actually that hard. So let's start with a dice probability that's equal to 8. So that's 6, 2. That's good. That's gonna be 6, 2, 4, 4, 5, 3. 6, 2, 4, 4, and 5, 3, and 2, 6, and 3, 5. So we have 5 so far.
There's a slightly better way. I'm sorry for intruding, but there's a certain pattern. If you want, you can even like graph it out. So the smallest values and the greatest values, 2 and 12. There's only one way to get that. The next values that follows that, 3 and 11, there's going to be one extra way to do it. So 2. And that same pattern will keep going until you get to 7, which is going to be 6 ways to do it. So you could just use that pattern and you can easily figure out. So you have greater than or equal to 8. So 1 plus 2 plus 3 plus 4 plus 5, which is 15. No
I
need
see.
to list it.
Okay, so does that make sense?
Yeah, yeah.
Okay, yeah, that's good. So we can list this as well if you want it, but that's good. So that would be 1/5 as the final answer. So let's see the next one. 3 standard 6-face dice of different color be rolled such that the sum of the numbers is 10. Okay. Does anyone have any answer for this?
Yeah.
Yeah. For which one?
For
This
18?
one, I listed it out. I tried to find a smart way to like figure out the number. Some of the rules is 10.
Well, there's actually a really easy way to do that.
But
So-
yeah, there is a way. I just don't remember it.
So
But-
what you'd want to do is you just want to wait a second. Yeah, you'd want to I'm pretty sure what I did is I listed how many ways you can get 10 and then scramble that. But like what you do to list them is actually just really simple. So first you start with 6, and so the only ways to list it are 1, 3, 6 unique combinations. So we'll start 1, 3, 6 5 5 1, 5, 4 5, 4, 1.
How about 6, 2, 2?
Oh, 6,
There's
2,
a
2, yeah.
way to list it smartly using stars and bars.
6,
Yes,
2, 2.
there is a way with star and bars. That is something I
That is the better way of doing it. I just don't remember like because you have at least one you have to give to each number. So then the sum of each number is 7. And you have 3 numbers. So do you do 7 plus 3 minus 1? Choose 7 choose 3 minus 1 2. So like 9 choose 2. But that's not equal to 27.
Well, like that I think that's good. But like I don't know, I feel like with this one it's only 10, right? It's not like you have like 15 dice and like some 24. So I think listing it isn't a bad strategy. Stars and bars would be better, but I think if you're proficient at one method, you could probably get it to do both them in roughly the same time.
So
period.
I recommend you guys to try listing as I just did now, because sometimes you will be confused to use how to use the star and bars based on the question you have. If you really feel you are good with that, make sure you try either way, and if you have time. But for now, I'll do this one, and then I'll kind of give you some hint for the star and bars to move on. But these are all different cases if you want to get 10. Am I correct with my listing before I
Yeah.
move on? Like I start with the largest number, right? And then 6 and 1 is like I can choose those, and middle should be 3, and then I just decrease those as we go. And we want to find they are different colors, which means if I get 6 from like maybe yellow, maybe 3 from red, and 1 from white, is going to be different when I swap those places, which is going to be different. Since we have all 3 numbers are different, so there are 6 ways to arrange these, and then only 2 numbers are the same, so 3 ways to do this. And then this is also 6 ways, and then this is also 6 ways, and 3 ways, and 3 ways. So we have 1, 2, 3, which is 18. And then 1, 2, 3, which is 9. So that's 27.
That's it. You don't really have to care about the different colors. That's the only thing. You just make
Yeah, that's something I figured out. Yeah.
Yeah,
'Cause,
I
like-
did not figure that out, that I just entered wrong, but until I saw the answer.
No, I answered wrong because I'm dumb and I didn't see I didn't see how many ways. That's how it's probabilities. So I got 1/8.
Okay. Yeah, they're just asking the counting.
So when I ask for colors, it doesn't matter.
It doesn't matter because you're
Well,
still
think about it. So look,
considering
if I
all
have
the
1, 3,
anyway.
6, that there's 6 ways to scramble that. If I change the colors, that won't change anything. There's still 6 ways to scramble it.
Yeah.
Like, yeah, when you have different colors, different like stuff, you
They just do this to trick you.
yeah. So like for the star and bars, you can just do such a thing. Let's say x1, x2, x3. These are the numbers that you get from each row. And then this has to be 10. But we do have some restriction. Like if this is the question, if I ask you how many ways can I like get a solution, positive integer solution to this equation, what do you guys say?
So easy. There's 10 stars and I believe 2 bars.
Wait, is x1, x2, and x3, are they non-negative numbers or are they just positive numbers?
Just positive.
Yeah, so easy. You have 10 stars, 2 bars. Just continue from there. It solves.
You have 7. It's
9
like
choose 2, right?
choose 2, because 7 plus 3 minus 1,
Yeah.
9, and then 3 minus 1, 2.
Yeah.
Is it 7 choose 2 or 9 choose 2?
9 choose 2.
9
I
choose
think.
2.
Okay, but if I ask now, if I change the question, if the these numbers x1, x2, x3 has a limit, like I'm gonna call xi to make it general.
Yeah, that's the limit.
So if I have some sort of restriction for those numbers, I cannot have 9, I cannot have 8 because these are the numbers on the dice. We do have some sort of restriction. And this is the time we are gonna kind of change the star and bar slightly. But ask yourself how we can play with this, like if this is my kind of restriction. But I will move that later. For now, I'm gonna let you try explore this on your own, okay? So let's see the next problem.
That's easy.
Okay, the probability of rolling 6 as the sum of the dots on the 3 fair dice. Express your answer as a come. Is it the same as the previous one?
No,
It's
it's
basically like one and the same.
they're similar, but like little bit different.
Okay, like who is gonna help me then? We are gonna get a 6 of the sum of the 3 fair number, right?
Yeah,
Like, should I go with like 4, 1, 1? That's 6. And then I can go with 3, 2, 1. And I cannot really change much, so I can go with 3, 1, 2, which is the same. So 2, 2, and 2. Is this only 3 different ways to make that 6?
5. Yeah, that's it.
Okay, and then can I swap these numbers 3
Yeah, you
with?
can pop it 3 times. That one 6 times. That one 1 time.
And
So
then
you got 10 over 216, so 5 over 1 over. It's an easy problem.
Yeah.
Managed to misunderstand it though.
okay, I think that's the case. So let's do number 20 as well.
Okay, number 20, the same way I failed.
Number 20 is easy. It's
Yeah.
like basically you list it, but it's a little bit, but you can list it a little bit smarter because the maximum number you get is 18. So what you're doing is you're basically just removing 3 strategically. So how many ways can I remove 3 from 666? So so I can remove all 3 from 1, and that gives us 3 possibilities because I remove all 3 from the first one, all 3 from the second, or all 3 from the third. And I can remove 2 from one and 1 from another, and that gives us 6 possibilities because that's 3 choices for the first and 2 choices for the next, and I can remove 1 from each. That's 1 possibility. So I believe that's just gonna be. Wait, is that the correct answer?
Yeah,
10. Yeah, 10.
yeah, you just removed 3. It says
3
6
plus 6 plus
1.
1, 10. Yeah, I'm right.
10. That's like one of the previous answers.
Okay, that is correct. So let me write what you actually said. This is good. Like I'm gonna do the longer way still because we have 15. So we should choose the larger values, which is I'm gonna start with 6 and 6, which is 12. So I can get 3, and then I can get 6, 5, and 4.
Yeah.
And there's nothing really I can. So I will go with 5, 5, and 5. And these are all options. So this is 3 ways. This is 6 ways. This is 1. If you add them, you got basically 10 of these. That's the answer. But instead of doing this, let's remember x1, x2, x3 is 15. But since largest number is 6 for each of these x's, and instead of dealing with this, if you choose the largest value of these numbers, you get 18. And I will say instead of dealing with that, x1 prime, x2 prime, and x3 prime could be 3. Why 3? Because if you add this, you will get 18. So you are telling me basically, if this number is 6, then this number will be 0. If this is 4, then this will be just 2. You are just kind of trying to find a way to make them as 6. What number you are taking away, which is Drew was trying to say. And you can kind of approach that way. And the question is asking how many solutions do I have for this equation? But do I look for negative number, like zeros as well, okay, in this equation, or just positive?
Mm.
Are these zeros are okay on this part? What do you guys think?
For the bottom die,
Yeah. Can I do zeros on this equation?
yeah.
I
If-
can
If
because
if the top one is related is 6 and its relation is going to be 0, then yeah, you can do 0.
yeah, because if this is 6, then this is 0, right? So which is possible. Then if I use the star and bars, I have 3 stars. and then 3 like of like bars, and then I just subtract 1, choose 3 minus 1 if you do remember. That is 5, choose 2 basically. And which is 10 also. Any questions?
No.
Okay, so I think we can stop here for now.